Welcome to GetXAIML. In this video, we'll understand the k nearest neighbor algorithm in depth with examples. Let's begin. K nearest neighbor is a simple classification or regression technique. So it's a non-parametric. Non-parametric means what? For example, if you take my linear regression, we have these parameters, right? Slope, intercept, and all those things. So these parameters decide the value. It is a parametric example. Non-parametric means there will be no parameters which you get. Okay, will not estimate any parameters. All the predictions are based on the data itself. Okay, predictions are based on the data itself. So this algorithm is also called as lazy learner. Lazy learner means what? It is only dependent on data. While training, it only stores the data. While training, this algorithm only saves the data. It will not train anything from the data. It only saves the data. So when we go for prediction, then only all the calculations are done. All the calculations or all the prediction are done during the prediction part itself. So computation is not done during any training. That is called the concept of lazy learner. This algorithm works well for small data set. We will see why it is so once you understand this algorithm. It works well for small data set. Let us try to understand the concept. What is the concept? Let us take an example. So let us say there are two clusters or two categories. So let me represent category as circle. It is one category. So let us say there are these are data points on XY plane. There are some circles. And say there is another category called squares or another cluster you can say. So it will be like say squares. So these are the two categories or my clusters. Now, what exactly this does algorithm? Say there is a new point X. New point X. Now our goal is to find which class or category this belongs to. This new data point X is a say new data point. So to classify it as category 1 or category 2, that is circle or square, which category it belongs to. What this algorithm says, k nearest neighbors. You find some nearest neighbors. Okay, k nearest means some value, some integer value take. So let us say I will find out 5 nearest neighbors to this X. Okay, so assume this is one of it. This is one, this is one, and this is one. So let us say 5. So 1, 2, 3, 4, and 5. Okay, I found out 5 neighbors for this. What it says, how will you classify now? You take the majority. Which one has the majority? The circle has the majority compared to, sorry, square has the majority compared to circles. That means there are 2 circles near to it and 3 squares near to it. So I will choose this as the category. So because this is majority, so 1, 2, 3, I'll select these points. So this means this X, whatever new data point has come, is classified as a square. This is how the basic concept of k nearest neighbor algorithm is. Okay. So final my category, this X data point will be classified as square. This is how it works. The basic understanding of this. Now let's understand what is this k. So k means it finds out number of neighbors. Okay. So k will give you how many neighbors I have to find. Okay, number of neighbors. Once I find the number of neighbors, I have to calculate the distance between their neighbors and then find out which one is the nearest. So I am just finding two things here. What is k? That means how many numbers I have to find. Tells us how many neighbors I have to find, and what is the distance between the neighbors. Okay, minimum distance between the 5 neighbors. You choose those 5 neighbors, for example, or k neighbors, which has minimum distance to the given point. So, for example, here for x, I have to choose 5 neighbors, and then which 5 neighbors for which the distance between them is minimal. Okay, first 5 minimal distance points. Okay. Now, this k will have effect on the algorithm. Okay. If I choose very large k, means if the k value is too large, that means what? If I choose too many neighbors, okay, for example, say for this example, I'll make k equal to say 12. So that means I have to choose 12 neighbors, they are minimal. So it may cover say this so much of area. Now if you observe, the model becomes too general. That means it is not able to capture many patterns here. So the entire thing is considered as one pattern, right? So there will be many patterns inside this different values, different data sets, different points. So it becomes too general. That means too much of high bias. That is high bias, because model becomes too simple. Model becomes too simple. So this we call it as what? Underfitting. It is not able to capture the patterns in the data. If I reduce the k value, means if I reduce the number of neighbors I have to find, it becomes too complex. That indicates high variance. Okay, that leads to overfitting. So, for example, if I take k is equal to say only 2, 2 means, or say 3, 3 means, so this circle becomes very small, only 3 I have to capture. Then that means what? I may capture more noise also. So more noise also, unwanted data. So that leads to overfitting. So now again, how will you choose k? Again, you have to go for variance bias trade-off. What is variance bias trade-off? So let us take for intuition. So this is what is, say this is variance, and this is bias. So too much of bias leads to underfitting. Too much of variable leads to overfitting. So my k, I have to choose my k such that I am optimal. This is optimal point. To choose k such that it is not too high or too low. It is optimal. How will I find? Based on the bias variance trade-off. So that is the concept of how to find, not how to find, what is the concept of k. So how can k impact your KNN algorithm? Now we'll see what are the different methods you can use to find k. So we'll find this parameter k, not parameter, value k. So the first technique used is very frequently used technique is k-fold cross validation. What it says, it's very simple. You divide data set with n points into k parts is n by k. Okay. Once you get this, you take this parts and then use some, say for example 80 or 70% to train, and then some 20% say to test, for example. Okay. Then out of the test result, for different values of k, you perform this for different values of k. Different values of k. For each value of k, you will get accuracy result, right? Test accuracy result. And then you take the average of it. So k will be equal to average of accuracy results. So which one, for what all k you got the good accuracy results. So you consider that and take the average. That will find your k value. This is one method. So k-fold cross verification validation we'll again see in the further videos in depth with examples. So that's actually the basic idea of how you apply the k-fold cross validation. Now second method you can use is called as elbow method. In this, what is the concept is very simple. So in your training or in your test, you get some error. you got some error. You plot that error with the different k values. Okay. With initially small k value going to larger k value. So this is x-axis is k and error is the y-axis. So if you observe the pattern, the error initially will remain same and then it may drastically decrease and then it will be ever decreasing, but the decrement is negligible from here. For example, this point. From here, if you observe, this will be my optimal k. You find out. So if you observe this curve, it looks like a elbow. So where that the elbow point, you will not find exact minima here, but some point where you observe that the decrement. So from here, if you observe, take this point, and if I observe here, the decrement is there still. It is ever decreasing. The curve is ever decreasing, but still consider to this the drop in the error, and consider from here to the drop in the error is too negligible. So from this point, you can choose it as the k value, which will give the, it will try to balance the error. So for both methods, you usually choose k as odd values. The concept is simple. 5 odd values. So suppose say that I have some data points of different classes, okay, squares and circles. Now, for predicting the class of new variable or new data point, I have to choose some k value. So if I choose k equal to say even 4, then what will happen if I the two nearest neighbors are these two and these two? Then they will become equal. So it will become difficult to classify which one, whether it's a square or a circle, because there is no majority, it's equal now. So if you choose the k equal to 5, definitely I will get one more neighbor from here. So that means I can choose this as the predicted class. Okay, that is a classification. That's why you usually prefer to choose odd values. Now we'll see how to calculate the distance. There are 3 techniques or 3 formulas. So the distance matrix is important. So first thing in this KNN is what? The k value is important, and then second is the distance, minimum distance between the point to be predicted and then the given data has to be calculated. So second thing is distance. So distance between any 2 points can be calculated using Euclidean method. This is the first one. So we will calculate Euclidean distance between any 2 points x comma y, say 2 features, 2 different data points or features, is given as square root of summation of I equal to 1 to n xi minus yi whole square. Okay. The difference between square them and then take the square root. This gives me the Euclidean method or Euclidean distance. It's called Euclidean distance. Now, the second one, you can use something called as Manhattan distance. Manhattan distance. So this is given as d of x comma y, distance between 2 features, as the absolute difference, the absolute distance between these points. Okay, the absolute distance between these points. The third one is Minkowski distance. It is actually the combination of these two. So if you observe, I will calculate Minkowski distance is d of x comma y is equal to take summation of I equal to 1 to n xi minus yi to the power p whole to the power 1 by p. If you observe, if I put p is equal to 1, it becomes Manhattan distance, same as Manhattan distance. If I choose p equal to say 2, it becomes Euclidean distance. Okay. So this is also called as L2 norm. Okay. Like just like your penalty term in ridge regression, that is also L2 norm. Manhattan distance is call it as L1 norm. Level 1 normalization. Level 2 is level 2 normalization or regularization. Now, the Euclidean distance is sensitive to outliers. Outliers means what? For example, in this, I have some data points here. Okay, they are far away from this. So when I calculate the distance, so it becomes sensitive. Means what? The data predictability changes very drastically. So it may not be so accurate if there are outliers in my data. Okay. So, and also it is not scalable. Why? Scalable means if I change the values relatively in the data, so there will be a scalability issue. I cannot scale or extend it to a large data set, or I cannot decrease the data set. The predictions may change. It's not slow scalable. So for that reason, we usually prefer Minkowski distance, okay, which balances both. It is not so sensitive to outliers and it is not so scalable. This also helps in scalability. Okay. The next is the effect of dimensionality. So what is dimensionality here means number of features in your data. Okay. So for example, features means what? If you want to calculate, say, or predict whether the student will pass or fail based on the number of hours he studies per week and the attendance percentage. So there are two features now. What is attendance percentage? One feature. Number of hours he studies per week is another feature. So that is the number of features. So if I go on increasing the dimensionality, if I go on increasing the number of features in my model or data set, so how it will behave? Higher dimensionality implies reduction in accuracy. That's why I told in the beginning, this works for small data set or small number of features. So reduction in accuracy, because if there are too many features, that means I have to find too many classes. So too many distances, then it becomes confusion for the KNN algorithm. So too many dimensions will not help. So it reduces the accuracy. Why? Because we visualize like this. If there are some data points, okay, some data points, all these different colors are indicating different features. So if there are too many features like this, as the number of features increases, you see a new data point comes now. So a new data point comes somewhere here. Now the distance between this and many data features becomes indistinguishable. Means the distances, okay, between different data categories, points of data in different categories are indistinguishable or remain similar. So how can you now classify? So for example, there are, say, 5 different dimensions, different variables, okay, or predictors. In that case, the distance remains same. So then how will I classify? Which one I will take? So that is the problem. So even if you take the optimal k value, that is the number of neighbors, but if it gives all the same values, all the same minimum distance for every neighbor, then you cannot find which category it belongs to. So that's why if you increase the number of features or dimensionality, then there will be a reduction in the accuracy. Now this KNN, k nearest neighbor algorithm, can be used as two things. In the beginning, first point I explained, it is can be used as classification technique, or it can be used as regression technique. So when I do classification, I usually go for the rule of majority. That means what? I will select, say, k neighbors, and then I will check which of the neighbor has the number of neighbors which has the minimum distance. So for example, I have two class, circle and square. This has 2 neighbors and this has 3 neighbors. So I will go for the majority, right? So that is how you do classification. Regression means I will take the average value. That means the circle in the square, let us say there are some values given. So this is 2, this is 3. So I will go choose this. Okay, I will choose this class and then say the data points are x1, x2, x3. That what I have chosen. So I will take the average values of this, because in regression I have to predict the value, right, to give some value. So y equal to say 3.2, something like that. So I will select the majority class and then I will take the average of all these data points. That will give me the I can use in that way KNN as the regression algorithm. Okay. So we'll take an example, you'll understand. So let us take this example. First, we'll solve it as a classification problem. So they are given the data sets of the students with two input features. The dimensionality is 2. They are given our studies and the attendance percentage. And they are given the result. There is a label, pass or fail. So given a new data point, you have to predict to which class it belongs to, whether it is passed or failed. So let us use the Euclidean distance to calculate the distance, minimum distance. So that is, how will you calculate? So let us take this point as the new point. Okay, let us say this is a new point. So I have to calculate the distance between all of this. So from A to N. So what is that I will use? Square root of xi minus yi between these two, A and N whole square, summation of this. Now let me write the distances. So with A, respect to A, if I calculate, I will get this distance as square root of. So what is, I am doing it for this feature plus this feature. Okay, that is the summation for all the dimensions. So here it is 8, 5. So here 65, 90. Okay. So you take the difference and then add them. So there are two features. So summation of I equal to into 2. So what I will do is, this is 8 from A and 5 from this new square plus the other feature 90 minus 65. So if I calculate, I will get this as 25.18. Similarly, we will calculate with respect to B, C, D, E. So there are 5 points they are given. So with this, the D will come out to be 20.10. We will calculate. Here D will be equal to 5.09. Here D will be equal to 10.20. Here the Euclidean distance will be equal to 10.05. That is what I am finding from N to A, N to B, N to C. This is the distance. Now you arrange them in the ascending order because I want the shortest distance. So with respect to A, this is to find out the sorting order. So this is minimum. Okay. Then next minimum. Then this one, and this one, right? So you write that in the order. First is C, E, D, A, B. And what the distance value? So distance is 5.09, 10.05, 10.20, 20.10, and then 25.18. Okay. This is A actually, and this is B. Now, so these are my data points, and this is the distance. And what is the result from the table? So they are given here. C fail, D fail, right? You write in the same order. So it is, this is fail, this is pass, fail, pass, and pass. Now, so you arrange the order of minimum distances. Now, how you classify? For that, they are given K is equal to 3. You select 3 neighbors. So in this table, what are the 3 neighbors here? So 3 neighbors I have to select. Which 3 neighbors? I have already taken the minimal. So which are the 3 nearest neighbors? The first 3 nearest neighbors. These are the first 3 nearest neighbors. So these are the first 3 nearest neighbors. Now if you check their categories, there are 2 categories, classes, that is pass and fail. Pass, there is 1 out of 3. Fail, there are 2. So majority is this. So this candidate, the new candidate, okay, belongs to class or classified it as fail. Those inputs with 5 hours study per week and 65% attendance is predicted as fail. This is how you apply the KNN algorithm. The same question we'll apply it for regression. Regression means I have to find out what is the average marks he gets or what is the marks he gets with this input. Okay, what is the marks you can predict. So instead of pass fail, here they are given the marks scored by these students. Again, the same concept. You apply the Euclidean distance and calculate the minimal distances. So, but take everything remains same. Here, everything remains same. Find out the minimum distance, our studies, attendance, and marks. This is what I am going to predict. So you don't consider it as the input. So for with A, the distance is, we will get it as 25.18. With B, I will get it as 20.10. C, I will get it as 5.09. With D, I will get it as 10.20. With E, I will get it as 10.05. So now again you arrange in the ascending order, that is E, E, B, B, and A. Now write the distance 5.09 because I am sorting them in the ascending order. 10.05, 10.20, B is 20.10, A is 25.18. Now instead of the class labels, I will have what here marks. Write down the marks of the students. C's marks is 65. Okay. E's marks is 80. B's marks is 60. B's marks is 88. A's marks is 92. What is the K value? Again, you have to choose the three nearest neighbors. So three nearest neighbors are this. Okay. So there in the previous example, we classified because here it was the labels pass or fail. So for regression, you can take the average of these three. So the marks scored by this new student. Okay. Estimate of this is 65 plus 80 plus 60 divided by 3. So this comes out to be regressive value is 68.33. This is the answer. This is how you can apply KNN for regression as well as classification. Most of the time for the data sets, in the real world, it is applied for the classification. Thank you for watching. In the next video, we will solve few problems on the concept of KNN algorithm. Please like, subscribe.